Microphone check, 1, 2. Hope y'all can hear me. Y'all give me a second here. That's the topology we're working with. Here I go. You are now tuned into the NetworkBruh, YouTube channel that takes complex networking topics, dumbs it down to a more simple language. We're gonna do a lab on MST again. I hate my phone. I hate my phone. I hate my phone. Look at this thing. Don't want to get prepared for this stream here. Y'all know what it is. Go ahead and cable up 2 distribution switches, just like this right here. Does this work? No. Where the pen at? Brush. Bam. Bam. Got a distribution layer switch 1. Distribution switch layer 2. Or distribution switch 2. And access switch number 1. Go ahead and cable up redundant links that way. 1 link this way. I actually have a gigabit cable going between those 2. But these 2 right here, for me, are fast Ethernet ports. Fast and fast. So my interfaces are going to be different from yours. But if you're using GNS3 or even G, go ahead and cable them up just like that. We're labbing from the book, the CCNP lab manual. Now, I've had mixed reviews about this book right here. So I said I'm going to go ahead and give it a try for this stream right here. We'll see how it goes. But y'all know how I am about the one-on-one labs book. I love that series. It challenges us. It says go ahead and do this, and then you have to go ahead and do it. This kind of does that, but it also kind of gives me the answers. I don't know if it's because I got the instruction version or what, but I said I'm gonna go ahead and give it a shot. I'm just gonna go ahead and give it a shot. So my guys are already cabled up, right? I already have them powered on. Here they go right here. That's switch 1. I guess I can go ahead and change the host names while you guys get those cabled up, just like this right here. So y'all go ahead and cable them up, just like that. The link in the description for this book, the link for this book is in the description box of this video. So if y'all want to get a copy of this book, so that way y'all can follow along and stuff like that, you'll see a link at the bottom of this video. Again, it's for the CCNP ENCOR book. Today we're going to be going over multiple spanning tree. So again, it's another flavor of spanning tree. It is open standard. Meaning you can use it with multiple vendors and stuff like that, but it was developed, Cisco was involved in the development of this spanning tree protocol, so just like rapid PBST and stuff like that, but again, this is an open vendor one. Also, MST was standardized as an IEEE 802.1s in 2002 and merged into 802.1q in 2005. MST is an open protocol derived from RSTP, so it's kind of like RSTP's baby, just a little smarter, you know, because the thing is with rapid per-VLAN spanning tree, right? Remember we, in the last, was it the last stream? No, the stream before that, we were creating spanning tree instances for every VLAN, right? So we had VLAN 20, we had a spanning tree instance for it. VLAN 30, we had a spanning tree instance for that. 40, 50, etc., etc., etc. We have, if you have 100 VLANs, guess what? You have 100 spanning tree topologies that you got to work with, right? Well, multiple spanning tree can combine those into one instance. So we could have, like, say, I don't know, spanning tree, or we could have VLANs 1 through 50 and put them in instance number 1, and then 50 through 100 in instance number 2. So we working with 50 VLANs, but guess what? We only have 2 instances of spanning tree. So it causes less overhead on the CPU and stuff like that. And I ain't gonna say it's a lot easier to work with. It's a little, the configuration is not that hard, but it's just different compared to the other flavors of spanning tree. So y'all let me know if y'all got any questions or anything like that. Y'all know I just like to do a little brief overview of what we're gonna go work with today. We got Sam Rocky in the building. Appreciate you for tuning in. He said 55. What that mean? Was that page number 55 in the book, or I don't know. Y'all can hear me though, right? Please let me know if y'all can hear me, because y'all know I've been having issues with my streams and stuff, with my videos or whatever. I got the lighting, got my, you would think episode number, it says 88. This is actually supposed to be episode 89. Episode number 89. You think I would have had this straight by now, right? Let me make sure, though. I think this is episode 89. Let me verify that, though. Y'all run me with my likes. Appreciate y'all for tuning in, man. I appreciate y'all for rocking with me. Again, when I get to about 5,000 subscribers, that is my goal. Let's see. Yeah, it's supposed to be episode number 89. We 89 episodes deep, man. Almost 100 episodes here, man. I've been doing a lot of live streaming, man. And when I started this channel, I was like, I don't think my voice 55. What you mean by 55? Am I too loud? Is it? Can you hear me? I don't know what 55 mean, man. Let me know. Voice 55. Hi, bro. You're gonna have to be a little bit more. You have to explain a little more what you mean by that, man. Again, I'm gonna give y'all some time, some people to tune in and stuff like that. We just trying this book out. I haven't really done this book. Let me see, did I have an older version of this book? No, not the older version. I had bought this book, and I looked through it, and I was like, I don't think I'm gonna use this book, so I returned it. Then I got it again, so I'm like, I want to try it. I really want to try it now. There's an ENCOR version of this book. There's also a CCNP and RC version of this book as well. I'm in Florida, y'all. We possibly get hit by a tropical storm. We are going to get hit by a tropical storm, but I don't know if it's going to hit my area. A thumbs up. Okay, appreciate that, Rocky. Yeah, Sam Rocky, man. Shout out to Sam right over there. So again, cable them up. Distribution switch 1, distribution 2, and access layer 1. I don't have a PC, although I could hook up a PC. I'm using hardware. I'm not using any kind of emulators. Y'all know I'm a proponent of using actual hardware. So I'm gonna go ahead and get started since Sam can hear me over there, and I don't see anybody else asking questions or anything like that. For this lab, again, we need 3 switches. And in this specific one, this is the specific models they use. They use 2 3560s with iOS XC, and then they're using the access layer switch. They're using a 2960 with the classic iOS. So this is using classic iOS. I'm using classic iOS on all of these guys, so I'm not too sure what features I may not be able to run. But you know, if you're going for like the CCNP and I think the CCIE, you have to use iOS XE. That's the recommended version that they want you to use when you're labbing and stuff like that. So cable to network as shown as topology. That was step 1. We only got, how many steps we got in here? Well, part 1 has 2 steps. Part 2 has a step 1 step. There's also a part 3, so I can't really count these, I guess, because yeah, part 2 has step 1. Part 3 has a step 1. And there's like these little subtasks within them, so I can't really count how many. And then there's a step 2. Like, man, come on, man. There's a step 3. All right, we'll see. We'll work with this, man. I usually do a practice run before I do these, but I'm like, let me just go with this, man. Can't front. I did not do that. So, task or step 1, configure basic settings for each switch. So basically, we're gonna do the host name. Give this guy D1. Give that guy D2. This guy down here is A1, right? So we all know how to do that. If not, then just go ahead and follow along. Switch 1 is actually going to be D1. Host name D1. Switch 2 is going to be D2. I don't have a PC connected there, so host name, he is D2. And then the third guy right down there, he's going to be A1, as you can see, right? So he's the access layer, right? Y'all remember what this is following, right? The Cisco's 3-tier hierarchy model. So we have the access layer here. We have the distribution layer here. Anybody know what the third layer is right there? If we had a third layer, there's 3 tiers in the Cisco's 3-tier hierarchy. What is the third tier? That's y'all pop quiz for today. So that guy is, host name is A1, like a steak sauce, right? All right, what else they want us to do here? They want us to do a banner. We ain't got to do all that, man. Spanning tree mode, rapid PVST. But then they say this is going to be MST. Huh, I don't know. He said run same. Okay, D1 and A1 run on same iOS. Yes, they should be. However, on mine, yes, on mine they're running same iOS, but in the lab they did say 2 switches are going to be running iOS XC version 16.9.4, and the access layer switch is running classic iOS, which is version 15.2, LAN-based image or comparable. And it also says universal image or comparable for the iOS XE. So either way, you should be able to run all of those commands if you're running at least version 15 or above. I would say. So, where are we at here? Where we at? Come on, man. Like, I'm trying to click this. What is going on with this thing here, man? Jesus. It's getting annoying. Alright, move this out the way. You gotta excuse me. This word is acting funky here. I'm trying to click the damn paper and it's not doing nothing. Let's see. We did the host name. They want us to pick the mode. So obviously we're gonna be working with MST, which is multiple spanning tree, right? Basically takes the VLANs. Instead of having an instance of spanning tree for each one of them, you're just grouping them in instances. So we'll go ahead and change the mode to spanning tree MST, right? So how you do that? Spanning tree mode MST, right? We could also verify, since this is out the box, what is it running currently? Show span summary is what we do to see what it's running. Right now it is running PVST mode. We want to change that to MST, right? So we global config mode, spanning tree mode MST. And then we do show span summary to verify it, right? Because we always verify our work. Show span summary. And we'll see now we are running MST mode. IEEE standard, right? Let's do the same thing on the third switch. So that way they're all running MST. Kobe said, how's the weather out there? Man, it is, it's getting a little dark. Let me see. It was a little drizzly earlier today. I had a lot of UPS power issues today, man. We had like, man, must have been like 15 switches down, all because of power issues, man. So typically I work from home, and this week I had to go. Today I had to go on site and yeah, take care of a lot of UPS issues, man. Just I had to replace. We have a separate team that handles the UPSs, but I had to take them off and put them on like power strips and stuff like that. Put in a ticket and have the UPS team take care of the UPSs, right? So a lot of power issues, man, because of the weather. So they were easy work, but yeah, it was just a lot of physical, and I had a camera down, so the Meraki cameras, we're running Meraki cameras. But yeah, right now it is kind of dry, and it is yeah, tomorrow, I think tonight we may get landfall from the not hurricane, tropical storm. It's Tropical Storm Elsa. I'm sure my daughter's excited about that, named after the Disney princess, right? Let's make him. Did we make him yet? MST, so spanning tree summary. He is in PVST mode, so we need to do him. Spanning tree mode MST. So now we're all running. So we'll verify our work though. Show span summary, just like my boss says. Verify your work. When you're done, verify it again. Verify it again. And then run another show command and verify your work. Switches in MST mode. This is what we were doing. All right, so what's the next thing we got to do? They want us to shut down unused ports, it looks like here. So, I guess for security purposes, we'll go ahead and do that. And then they want these guys in trunk, so we're not going to do all that. I'm not going to shut down the unused ports. But if y'all want to do that, y'all let me know. What they want us to do is have all these interfaces. So this is going to be similar to yesterday's stream. They want this to become a trunk. So they want this guy to become a trunk. This is a trunk. This is a trunk. That's a trunk, and that's a trunk. So all of them going to be trunking, right? Now we don't since they're probably in dynamic negotiation mode, or what's that? Switch port negotiate. That means we can make one side to become a trunk, and this side will negotiate to become a trunk, and then they will become a trunk happily ever after, because one is going to be actively becoming a trunk, the other one's going to just passively become one. So we can do the same thing on this side. So we can make gig 101, 6, and 5 to trunk. Now mines are fast Ethernet here, fast Ethernet here, and this one for me is also that's a gigabit Ethernet port. So your interfaces might be different, right? Let's go to distribution switch number 1 and do that. Interface, what's that? Gig 101, and then fast Ethernet Come on, you can't do that? Or you can do a range like that. That's what it is. So I'm gonna start playing with that range mode more often with different types. Control E, and then fast Ethernet 105 through 6. Just like that. Y'all see how that combination? See, I didn't really know you could funkify it like that, man. So switch port, we got to do trunk encapsulation first. Now, iOS XE, you ain't got to do this, right? But I got an older version of iOS because y'all know, because I can't afford the new hardware. Or software, rather. Come on, man. This app, man. You messing with me. .1Q, and then switch port mode trunk to make those trunk, right? And they should come down and then come back up. They bounce. Good to go. We can verify our work with show interfaces trunk. Oops, show interfaces trunk. And there we go. We are trunking on all of these guys. Fast Ethernet, and Gig 101. Right? Good to go. We can verify our work on the other side, right? Because see, this is encapsulation.1Q, right? We go to the other side, so let's go to D2 right here and verify he's trunking, right? See, we already see that that interface went down, came back up, which was this guy right here. And we do a show interfaces trunk. He is also a trunk, Gig 101. So right here, it is a trunk. And also we have this N here that lets us know it negotiated to become a trunk. Notice the difference, right? This has just 802.1Q. That side says N.802.1Q. So it negotiated that encapsulation. Y'all got any questions so far, or y'all lost, or if I can't get to it, there's a lot of smart people in the chat room over there. Y'all run me my likes, man. I appreciate y'all for tuning in and stuff like that. Again, I'm gonna do a giveaway at 5,000 subscribers. What is that giveaway, right? What am I giving away? I think I already gave that away. Told y'all what I was gonna give away. And let's verify on access layer switch 1 that he has 4 interfaces trunking, right? Let's do that. Let's do that. I know we probably did it, but we need to verify our work, right? Show interfaces trunk, because we always do that. Show interfaces trunk. We got FA101 trunking. 102 is trunking. So 101 and 102 is trunking. But what about 3 and 4? Why aren't those trunking? Ha ha ha. You know why? Because we did this side, but he's not connected to this side right here. So we need to do that side and make this trunk. That is why that didn't happen. We'll make this one actively become a trunk, and then this guy will passively become a trunk to make this a trunk. Right? So let's go to D2. Go to global config mode. Interface range. What's that? 5 and 6, right? 5 and 6 right there. GI. No, those are fast Ethernet for mine. So again, your interfaces might be different. 105 through 6. Switch port, trunk, encapsulation, .1Q, switch port mode, trunk. Again, if you're using iOS XE, you don't have to do that right there. Show interfaces trunk. And we should now have 4 interfaces trunking. We only got 2, 3. We got Gig 101, 5 and 6. I meant, yes. So on this guy, he's got 1, 2, 3 trunking. And then A1 needs to have 4 trunking. So now we show interfaces trunk. And there we go. We got 1, 2, 3, and 4 trunking right there. That's right. Right. 1, 2, 3, and 4. All of those guys are trunking. Good to go. All right. So what's the next task they want us to do here? Let's see here. We did those trunking. They wanted us to shut down those interfaces, those unused interfaces. I ain't gonna do all that, man. We could if we wanted to, but we ain't got to. They want us to create VLANs. It looks like 2 through 5. Morningstar's got a question. Appreciate you for tuning in, Morningstar. He's finally in the building with NetworkBruh. NetworkBruh is doing his thing. I'm getting set up. Be right with you. Okay, man. Typically I stream Monday through Thursday, 8 p.m. Eastern Standard Time. So, you know, I have that little countdown at the beginning right at first. So that means really 7:55 I start streaming, and then you'll see the little countdown. I start at 8 o'clock, but then I still, you know, talk shit for about 10 minutes and probably go over current events and stuff like that and give you guys time to cable up. So I know you just tuned in, but basically we only need 3 switches. 1, 2 distribution layer switches, 1 access layer switch, and then make all of these guys trunk, just like that. Your interfaces might be different. Again, the link for this book is in the description box below. This book is not, this lab is not from the 101 CCNP Labs book, though. This is a different book. This is Cisco's lab manual. So I'm just trying something new here, and this is something that I added to our studies. So I said I wanted to see. I wanted to see what we're working with. So hang on. Okay, so we did the interface there. All right, so they wanted us to create VLANs 2 through 5 and name them. Let me see, do they want us to do that on all these guys? Yes, they do. VLANs 2 through 5 and name them second VLAN, third VLAN, fourth VLAN, and fifth VLAN, just like that. And then what they want us to do with it. And that's it. That's it. So second VLAN. All right, so we'll go to, and do they want us to do that on all of them? Let me see. D1 needs that. D2 needs it. And yes, D3 also needs it. So I'm going to start with distribution switch number 1. Go to global config mode. Global config mode. And then they said VLAN 2. For some reason, they couldn't think of a better name. They said they want us to name it second VLAN, just like that. And then third for the third one, fourth, and so on and so forth, all the way up to the fifth VLAN. So VLAN 3 is name is third. If I can spell VLAN. VLAN 4 is name is the fourth VLAN. And then I'm gonna go ahead and go to my running config, show run. We're gonna say section VLAN, and then just copy and paste them bad boys to the other ones. That way we ain't got to do all this all manually, right? So we go to switch 2, go to global config mode, paste them bad boys in there. Think about doing that for the last stream. I don't know why I didn't do that in the other stream. Because they got different names on these. That's why. Global config mode on these, and then same thing on this guy. Oh, I forgot the fifth VLAN, didn't I? I sure enough did. Yep. Let me do global config mode and say VLAN 5. Name is fifth, right? Fifth. Where's the my little sound effects there. Man, this app killing me, man. They be trying to put ads and everything, man. Crazy, man. All right, so now let's do a show run. Copy that again. Don't worry, we'll get to the MST part. Just need to do I need to do logging synchronous on this switch. Show run section VLAN, and then copy and paste those bad boys, right? I need to do those over again on these switches right here. Right here, fifth VLAN, and then the third switch. 5 VLANs. Good to go. Show our work with what? Show VLAN brief. We created those VLANs. They're good to go, right? They didn't say what ports to put them in or anything like that. Nope, they didn't. Outputs and show spanning trees. Topologies highlighted may be different than what you observe using your own equipment. It's critically important to make sure you understand spanning tree works, make a decision, how those decisions impact the operational topology of networks. So, like we mentioned, you can have different root bridges like that, and when you change and modify and tune your spanning tree topology, you affect how the traffic flows in your network, right? Right. Spanning tree is what we call that the STP stands for spanning tree protocol. It's a way to stop loops from happening at layer 2, right? So this PC right here, right? Let's say he's trying to get to the, I've explained this a million times in these past streams, but just in case, like my man Morningstar here, this is his first time tuning in, catching me live for once, right? We got a cloud right here that's going to represent the internet, right? Is the internet. I'm going to make him the cloud guy, just like the in the movie Trolls, right? Give him some shoes right here. My little daughter loves that little movie. He's gonna be Cloud Guy, right? Bloop, bloop. And when we need to get to the internet, we send a frame, right? And eventually to our router. We'll make pretend that there's a router in here somewhere, because that's our default gateway, right? This guy's our default gateway, right? So we get to the default gateway and we go out to the internet, right? But the thing is, you need to define a root switch, because that's where all the traffic needs. It's like the center of the network. All the traffic needs to go there before it goes out to the internet. So if we made distribution switch number 1 the root switch, if we make him the root switch, right, then the traffic that this switch needs to take to get to the internet, he obviously needs to go from the PC to A1 to the root switch, then there, and then out to the internet, right? Now, this may or may not be optimal depending on, you know, what models of switches. Maybe we want all of our traffic to go directly to the internet and bypass D1, right? So we can make this guy the root switch. It might be better to make it, since he's closer to the internet, right? It might be better to make this guy the root switch, right? So if we made him the root switch, right? R for root switch, then our traffic obviously is going to flow from here, make it to the root, and then out to the internet, right? That seems like a better traffic pattern if we do it this way, right? That's how and again, we need to go to our root bridge first before we go out to the internet, if we need to go out to the internet. That is how spanning tree works when we define our root switch and stuff like that. Why I still like it? I look like it's daytime, man. That's crazy. I don't know if a hurricane is like, it's like the calm before the storm. Y'all know what it is, right? Anyway, what you said? That's Miss Morningstar. Oh, I'm sorry, my bad. Miss Morningstar. I know there's some female viewers, but sometimes I'm so used to so many, like, you know, IT and just networking in general is a male-dominated industry and stuff like that. So my bad. There are women in STEM, and I appreciate you for tuning in. So he said, I thought you were CCNP Lab 4. Okay, no worries. I can follow along. Yeah, Lab 4. I'll probably do that one probably on Monday, because I don't know if I'm going to stream tomorrow. Tomorrow we got a possible hurricane and stuff like that. So I don't know. We'll see. So where were we at here? So yeah, we need to go to root switch before we go out to the internet. And again, spanning tree, the way it works is to stop loops from happening at the at layer 2, right? So we had this frame right here, right? It's possible that this frame could get sent over here, and he thinks the internet is that way, so he sends the frame that way, and then this one thinks, oh yeah, that PC lies on over here, and then it could cause a loop to happen, right? Well, spanning tree blocks that from happening or stops that from happening by blocking certain ports because of redundant paths or whatever, and it might make this particular port, maybe the root switch, the root bridge, to take us to this root switch and stuff like that. It works in a certain way, so that way loops like this do not happen on our network. So, and that is the beauty of spanning tree, right? So enough lecturing. Let me get right onto the lab here. What we said. Configure MST, what we came to do, multiple spanning tree. Configure MST on D1 and D2. Oh, by the way, Morningstar. So the reason why it seems like, I guess it would have been predictable for me to do lab number 4 today, because that's how I was doing it with the CCNA labs. But with the CCNP, I have this study sheet here that I haven't really been following, so I'm kind of jumping around here. So I said I'm going to be doing MST, right? What I basically did was I took the topics from the exam blueprint, and I said we're going to try to configure and verify. Took resources from that, so it's chapter 2 through 4 in the book. Some CBT Nuggets videos. I took some sample YouTube videos, some of which from that guy NetworkBruh. I don't know who the hell is that, but I heard he's pretty fire. And then for this one, that's what we did yesterday. We did lab number 3 to cover multiple spanning tree. Today we're doing the ENCOR book, which is this one here. The link for this book is in the description of this video right here, right? And then that's the lab we're doing, lab 412, implement MST. It's page 47 in the book. And then I don't know, the next stream we might do Boson NetSim. So that's the reason why I guess my labs haven't been predictable on what's going to happen next. And I used to schedule them. So we got Power Nod Shell in the building. Say, yes, I need this. Thanks, bro. Hey, appreciate you for tuning in. Appreciate you for tuning in. I'm not going to say bro anymore. I need to stop doing that. But yeah, I appreciate you for tuning in. Let me go ahead. I got my work stuff over here. Let me get rid of that. So yeah, make sure you join the Discord server. And I'm sharing this spreadsheet right here. This is my study sheet. So if y'all want to follow along and stuff like that, make sure you join the Discord server. And you get a copy of this spreadsheet here. Has all the resources. I broke this shit down, man. Look here. Took all the exam topics and said, okay, Ether channel is in page 2, between page 257 and 258 in the ENCOR lab manual, right? EBGP, chapters 11 through 12. I even talked about which CBT Nuggets video is going to have it. Some YouTube videos, right? Et cetera, et cetera, et cetera. The one-on-one labs book that we used to do, it's labs numbers 34 through 43, all BGP labs. Same thing with this book, et cetera, et cetera. So I broke it down. So you want to copy this spreadsheet? Make sure you join my Discord server. I'm going to put it in the chat right here. Boom. He said, I have the CCNP labs. I'll grab that manual too. That's what's up. And Kobe said, bro, appreciate that. So where would we at here? We were going to configure MST, right? Multiple spanning trees. So in this step, we will configure MST and D1 and D2 only. So we're going to configure MST on the distribution layer switches. Did anybody come up with the third layer for the 3-tier hierarchy? That was the pop quiz for the day, right? We said he's A1 because he's the access layer switch. He's D1 and D2 because he's the distribution layer switch. Cisco has the recommended what's called the 3-tier hierarchy. What is the third layer called? Right? We said access layer, distribution layer. What is the third layer called? Right here. We're gonna configure MST on D1 and D2. We'll do this only so we can observe their interaction with each other as well as their interaction with A1. We put it in MST mode. Right? At this point, with no MST specific configuration, MST instance 0 is operational for all VLANs. So remember, we already did at the beginning of this stream, we put it in spanning tree. We put the switches in MST mode for spanning tree, right? We verified it with show spanning tree summary, and we'll see that we are running MST mode, right? EEE standard, right? IEEE standard. Now, when you do this, there's several. Remember we said we map our VLANs to what's called MST instances. So instead of having VLAN 1 and a spanning tree instance for that, VLAN 2, a spanning tree instance for that, spanning 3, spanning tree or VLAN 3, a spanning tree instance for that, VLAN 4. Y'all see where I'm going with that, right? If we had 100 VLANs, then we have 100 instances of spanning tree, right? MST, you can combine them into like I said, we could put VLANs 1 through 50 and map that to one instance of MST, and then VLANs 51 through 100 and map that to one instance of spanning tree. Now we only have 2 instances of spanning tree, but there's 100 VLANs all together, right? So again, it's less overhead on the CPU and stuff like that, and the switch ain't got to work so hard, right? Now, there's one catch-all VLAN that's already built in MST. It's called MST0. They also call it internal spanning tree. It has all of the VLANs in it, right? And that is MST0 right there. So it has all of the VLANs in it, tells you which ones are forwarding, etc., etc. Let's just see, so spanning tree, right? Let's see what instances we have so far. MST-P, right? We're running that, and it's MST0. So all of the VLANs are on here, right? We don't have, like, remember when we was running classic spanning tree or rapid PBST, we'll see all of the instances. Like we'll have VLAN 1. Like yesterday's stream, we had an instance for VLAN 100, 200, 300, etc., 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 etc. We had 8 instances of VLANs, right? But we're gonna map them all together in one, and that's what we're gonna do here, right? So, and again, they said issue the show spanning tree, which we just did. We did the show spanning tree MST, which we just did also. Take note of the information displayed for gigabit 105 and 106. Because they are connected to a switch that is not running MST. Okay, so somebody was not supposed to be running MST. And I guess it was the access layer. So let me do that. Let me make sure the access layer switch, he is not going to be running MST. Did anybody come up with the third layer? Power Nashell got it. Actually, all y'all got it. Morningstar got it. Kobe got it. Power Nashell got it. Morningstar, all y'all got it. But Morningstar was first. It is the core layer. That is the third layer that we're missing. We can compare them to become one MST region, right? That is correct, Morningstar. So they're all in one region. And we can create, yes, exactly. So we can call instances, well, let me see. Let me take that back. You can have 5 instances in one region, if that makes any sense. So we have regions. So the regions, so it's almost like city, state, and then country, right? So we have the country will be the region. So region, right? And then we have the instance will be the state. And all the little VLANs, all those little VLANs within that instance are the cities. Does that make sense? Right? I just thought of that. That's fire. That was a fire analogy right there, man. So we have the states will be the region, just like Morningstar said, right? And then we have one state will be the one state will be the instance. So we'll have like instance 0, in instance 1, instance 2, instance 3, etc., etc. And then all the little VLANs are the little cities within the state, right? I'll just be coming up with some fire, man. Hey, listen, man, y'all fuck with me, man. All right, so let's go ahead and start. We need to turn off. Okay, on access layer number 1, we said he needs to be in spanning tree rapid PVST because that's what they had. Mode rapid PVST, right? So he's gonna be running MST. He's gonna be running MST, but he's gonna be running our PVST, and that's what they wanted us to see with show span. And they said 5 and 6. There it is right there. See, before they were all running peer-to-peer links, but this is peer-to-peer, but it's bound to PVST. So we're running 2 types of spanning trees here, because remember, MST is open standard, so you can run it and mix it, and you can have a mixed environment. Don't know why the hell you would do this, but if you want to have rapid PVST on one side of your topology or network or whatever, and MST running on this side, you can do that. You can mix and match with this, and it ain't gonna fuck it up. So, yep, perfect analogy. Yes, appreciate that. We can combine them. Yes, okay, so cool. All right, so where was we at? Show span tree. So we did that. Yep, we did that. We ran some show commands and saw that this is what they wanted us to take note of, right? To let us know that even though we're running, even though we're running MST on this switch, multiple spanning tree protocol on this switch, the ports on. So where we at? We're on D1, right? The ports that are here, right? That port right here, that port right here. It says we're bound to a switch that is using rapid PVST as opposed to MST, right? So that's what this is. That's what they're trying to tell us with this right here. The basic behavior of an MST is the same as spanning tree, where a root bridge must be selected, which is what I was mentioning about the root bridge, right? Then root ports, and finally best paths to the root bridge from all non-root bridges. In the current network, we can see that D1 has been selected as the root bridge, right? How do we see that? It don't look like it was, because otherwise it would have said this bridge is the root, right? Let's see. Let's see if maybe on mine's D2 became the root bridge. Let's see. Show spanning tree. Yeah, on mine, D2 is actually the root bridge. Probably because he has a lower MAC address. That's probably why he became the root bridge on mine. So, the bridge priority defaults to 32768, which it was. But then, yeah, it's 32768. So the election based on D1's having a lower base MAC address. Now that's on their lab manual. My physical switches, this switch right here actually has a lower MAC address. We'll even see that, right? D2 has the switch, and I think mine's, because I bought them all at the same time on eBay and shit. This is my MAC address on D2, right? That's his MAC address. We can compare that to this guy's MAC address over here and see who has the lower one, right? Switch 1 is 0187. 3.5, so that's a tie right there, right? 3.5 F7, tied there. So they're the same up to this point right here. It's the last 4 that's different. So in this guy, he's 0580, and this guy is, let me see, where is he at? See, oh yeah, that's what it is. So root ID, so the root. So this guy is 0580, and then this guy right here is 0800. So he has a higher one. That has the lower MAC address, which is why this guy became the root. So, like what I was saying with the cloud and shit like that, right? The cloud is over here. So, if we need to get to the internet, guess what? PC3 is going to go this way to the root and then out to the internet. And that's what we do with root bridges, right? And I could change it and make the other guy the root bridge if we really wanted to, and you know, tune our spanning tree topology if we wanted to and stuff like that. But that's just, we're not going to go to the deep into that, because then this stream will be about 10 hours long, right? So where are we at here? They want us to issue another show command here. I guess I could use this because I have the instructor version of this. So I guess I'll just be doing more instructing here with this. Issue the show spanning tree root command on D2 and the output will be different, which we did already, right? We can see we already did that. Right? We already see that this guy, and it says here, this bridges the root. So this guy, you drop this king, he gets the crown right there, right? So he is the root bridge, right? Give a little crown right there. Give him the root right there. Where we at? They want us to issue the show spanning tree root to see who the root bridge is. Even though we did this and it says this bridge is the root, but that's one show command that we want to get familiar with when we are experimenting with spanning tree, right? So show spanning tree root. This lets us know the one who is 0580 is the root bridge for the MST instance number 0. We didn't create any other instances yet. We'll probably do that later in this lab, right? I haven't done this yet, right? So he is the root bridge, 0580. Who am I? I am 0800, right? So this guy right here, he is the one ending in 0800, and he is the one that's ending in 0580. So 0580. So when we do show spanning tree root, if we have more instances, we'll see who's the root bridges for each of those instances. Well, we only have one instance that has all the VLANs in them, and this guy is a root bridge. This guy right here, the one who has the crown, he is a root bridge for all of the VLANs. We're gonna break that up. So, part 3: configure, tune, and verify basic MST operation. In this last part, you configured all 3 switches to run MST, which we just did. In this part, you will further configure, tune, and verify MST to support the unique topological. Say that 5 times in a row. Topological requirements. Step 1. Create and verify an MST configuration, which we've done yesterday's stream, right? To get into that mode, you do spanning tree, go to global config mode, and we say spanning tree, MST configuration. We do that, and you'll see we are in MST configuration mode for spanning tree, right? We could run this is the tricky one right here, right? We just do show by itself, right? And it'll show us the configurations that's pending right now. So right now we haven't done anything, so there's nothing pending. We don't have a region or city, or country, right? We don't have the cities or the VLANs that are mapped to the instance. The instance is going to be the state, right? The instance is going to be the state, and then the VLANs that are mapped to that state are the cities, right? So again, country, state, and then cities, right? So what else? How they want us to break this down? First, they want us to kind of like name our country. So in this case, they named it CCNP V8. That's the MST region. How do we do that? We just do name. You would think they would put region, right? So you would think, can you do region? No, you can't. So you got to do name. That's going to be so you notice it's blank right here, right? This is kind of like we're naming our country, right? So in this case, it's all caps CCNP lowercase v8, right? And then we're gonna name we said that we did the country. Now we're gonna do the state. So in this case, the state will be the actually we got to do our revision. We got to do a revision number because we could change it up and stuff like that. So let's do revision first. I like doing that. That's what we did last time. Let's just do revision 1, and then the instance. Once we do the instance, then we're gonna map the cities to it, or the state and then the cities to it. So revision 1, and then instance. How do we do that? I think you got to get out of this, right? Instance? No, it's instance 1, and then VLAN. Now we map the VLANs. How did they want it done? They wanted instance 1 is going to be mapped to VLAN 2. Why would they do that? I don't know. Whatever. On distribution layer switch 1. So instance 1 is going to have VLAN 2, and then they wanted instance 2 mapped to VLAN 4, right? Now, before we get out of this mode, right, we do a show again, right, which is actually going to show the pending MST configurations. This is what's pending. We mapped VLAN 2 to instance 1 and VLAN 4 to instance 2. Y'all with me so far? Remember, this is the one that came like free of charge, basically. Like it was already built in once we turned on MST. Had all the VLANs in them. Now we just broke it up, right? Remember, it had VLANs 1 through 4094, and we kind of broke it up. We took out the 2 and put it there. We took out the 4 and put it there. The rest of them stay in instance number 0, right? So we have our country, we have our state, and then we have the city within that state. Here's another state with the city in it. That make any sense? Y'all let me know if I'm like making y'all confused, or ask some questions, ask away. There's no such thing as a dumb question on my channel. Y'all know I'm gonna try to break it down as much as I can. So I hope that makes sense so far. Let me what else we needed to do here. So we did show pending. Now we could also do show current. What's currently running? What's currently running? Nothing. There was no, this is the default configuration for MST. Everything goes to the MST instance 0. So this does not like get enabled until we get out of the MST configuration mode. So we get out here, and now we do a show, do a show spanning tree MST, right? No, not show spanning tree MST. I think you just do show span MST. Which one did I wanted to do? Show spanning tree configuration is what I wanted to do. Isn't that what it is? Show spanning tree MST configuration. MST config. That's what I was looking for. That is the ones that we just created. So now it's in there. With me so far? Okay, so where we at? While in spanning tree configuration mode, you can do show current and show pending, which we just did. I just be thinking ahead, don't I? Like, let's stop tooting my own horn over here, right? Or toot my own bruh. So we did the show. Now they just wanted to kind of like look at the MST not configuration, but the VLANs that are mapped and stuff to it. So let's just do show span MST rather, and we'll see. Do they want us to do that on both switches? No, just that on D1. So we'll see that MST 0 has the remaining VLANs mapped to it, and then we have MST 1 has 2 VLANs mapped to it, right? Is it 2 VLANs? And that one has 4 that's mapped to it. That's interesting. Oh, because of the PVST ones, I believe. I think that's what it is. No? I would have thought it would have said 1 instance, because this is what I saw here, right? We had VLAN 2 mapped to instance 1, VLAN 4 mapped to instance 2. Right? Didn't we just do that? Let me see. Let me make sure I did that correctly. Yeah. Yes. VLAN 2, VLAN 4. Okay. Where we at? What else we need to do? This configuration does not propagate to other switches. Each switch exchanges digest information summarizing VLAN to instance mappings it has configured. If a switch receives a BPDU with a different digest, it assumes the sender is in a different MST region. The output below is what A1 shows and the topology used to create this lab. Notice the ports connected to it are classified as P2P. So now they want us to basically see what it looks like from this guy's point of view, even though he's running rapid PVST. That's an ugly ass arrow. This guy right here, they want us to see what his spanning tree topology and show commands look like. So go to A1. Sauce. Run me with my lights, man. Run me with my lights. Show span MST. It's not MST mode, so that's weird. Let's see. Yeah, we didn't map any to it. Maybe we also got to put it in that mode. Let's see, because I didn't think they put MST on A1. Let me make sure. Yeah, oh, at this point, they made D1 and D2 run MST. And then, let's see, did they put MST on the third switch? So, it don't look like they did, so I don't know. They didn't run MST on the third switch on A1, so I don't know why it would have even information on it if it's not running. Because see, notice right there, I did show spanning tree MST, and it's not in MST mode. Remember, we changed it to rapid PBST. But let's go ahead and change it to MST and then run it anyways. Let's see what happens here. Obviously, it's going to change the topology there. So spanning tree mode, MST, show span, do show span, MST. Now we should see spanning tree. And now see this is running all the VLANs mapped to MST0. So that's probably what they wanted us to do there. But it don't say where they wanted us to make this switch run MST. They didn't say. I'm not liking that book so far. They leaving stuff out. So we'd also do a show spanning tree MST configuration digest, which this command I didn't really know. I didn't know it runs. I guess it basically has MD5 on the these spanning tree topologies. So we do show span MST digest. No. Configuration digest right there, and then it shows the instances configured, the digest pre STD digest. I definitely have to look what that means. So he said, yeah, I'm following. Okay, appreciate that. Y'all got any questions so far, or I'm losing anybody or anything? Y'all let me know. Y'all know sometimes I'll be coming up with these funky analogies and just make it confusing for more people when I'm actually thinking that I'm making it more simple. But I hope this, this helps you guys out. If so, just then run me my likes, man. Run me my likes, man. All right, so it says here, as you can see, the digest values are different. I didn't. Let's look at the digest value for D1, right? So we do a show span MST configuration digest, and we'll see that ends in a 62DA 7B05. The other one had a so they're just completely different, man. So they got different digests there. Configure MST on D1 and change the revision to 2 and add VLAN 3 to instance 1. That's a lot to digest there. Pun intended. So configure MST on D1. So we're going to go to D1, which is this switch right here. Bloop. That guy. And he said, change the revision number to 2. So remember, we did revision 1. Let's change it to 2. So go to global config mode, and it's spanning tree MST configuration. And we're going to change the revision number to 2. Then we got to map some different instances to it. So, and I think you can only have one region, if I'm not mistaken, right? You can't have another region. Can you have another region? You may or may, yeah, you should be able to have another region. Y'all let me know. Can you have more than one region? Because if I change the revision on this, which one am I going to change the revision to if I do another revision? Let's see. I mean, another region. Let me see if I do another revision. Another revision. Another region. Let me see. CC. No, I don't want to do that because I want to fuck it up. Let's just change the revision number to 2, and I'm gonna do a show current. Actually, let's do a show pending. So we change the revision to 2. Right? I was wondering if you can do another region, because remember, just like Morningstar said, the name is akin to being a region. Can you have more than one region of MST instances? Or, I guess, more than one MST region? I'm not sure. Y'all let me know. So they said they want us to change revision number to 2. Add VLAN 3 to instance 1. And VLAN 5 to instance 2. Okay, let's do that. So instance 1 is going to have VLAN 3, and then instance 2 is going to have VLAN 5. Now we do a show pending, what we just did, and now we've got VLANs 2 through 3 on instance number 1, and 4 and 5 on instance number 2. So even though we've got 4 separate VLANs, we're only running, we're running 3 separate instances, right? Because remember, we have the built-in 0 one, so it kind of slightly, lowers the overhead on the CPU. What else we want to do here? Morningstar said, one region can support up to 65 MST instances, though. There's no limit to regions. Okay, good, good, good. Okay, that's good to know. I appreciate that. Appreciate that. All right. That's good to know. I'm gonna remember that one. I'm gonna remember that because like I said, I haven't touched MST in God knows how long. Where were we at here? So we did that. We did show pending. Now if we exit out, we'll see that this will get applied. We do a show current, what's currently running. This is the old one. This is the old way, right? We did only had one VLAN mapped to that instance. One VLAN mapped to that instance. We do a show pending. We have two VLANs mapped to those instances, right? Remember, they don't get applied until you exit out of this mode. Then they get applied, kind of like creating VLANs, right? Now configure D2 and A1 with the same configuration settings. Name CCNP version 8, revision 2, instance 1, VLANs 2 through 3, instance 2, 4 through 5. After completing the configuration on D2 and A1, the output of show spanning tree on MST should be similar to the following output. Okay, so basically what we did on D1, they want us to do it on D2 and A1, right? So let's go ahead and do that. I think we could copy and paste this too. Let's see. Show run section. What we want to do, spanning tree or just do MST? Let's do MST. Nothing. Let's do a lowercase MST, see if it shows up. There it is. So basically, we want to copy all that, save us some work here, right? Take note of those filtering commands, those parsers. You see how I did just show run? It said just show me the MST configuration for it. Boom. Now I can copy and paste all this shit, right? That way I got to do it all over again. Then I'm like, man, we gotta watch this man type all this stuff over again. No, we just copy and paste here, right? So go to switch 2, which is D2. Global config mode. Is this the configuration that's correct? Revision 2, instance VLAN, blah, 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 blah. Boom. Same thing on access switch number 1, or A1, source, drip. Boom. They want us to run a show spanning tree MST on alpha 1. Show spanning tree MST. I've been in law enforcement too long. I used to work at the police department. We used to Alpha Bravo and all this other stuff, man. Phonetics. So they want us to run this show command and see we have the same output as this guy. So we're running it on this guy right here, this show command, and it should theoretically have the same output as this guy right here, right? Remember, he still got the crown, so therefore he should still be the root. We didn't change all of that up, right? So remember, he was what, 0580? I can't remember. Yeah, he was 0580. So the root bridge for MST is, for that particular instance, 0580. What else we got here? This is MST1, instance number 1. Has VLANs 2 through 3 mapped to it. And he says the root bridge for it is ending in 0800. Interesting. So I guess this guy is going to be the root bridge for those other ones. Let's see. Let's see. Make sure I'm reading that right? This is one VLANs 2 through 3. Who is the root? Let's just do a show span. Let's do that so we can see who the root bridge is for what. Show span. MST 0. See, he's saying the root bridge is for MST 1. The root bridge is 0800. So he is the root for MST 1, which is what we knew already, right? What else we got here? MST 2, the root bridge for it is ending in 0800. So he is actually the root bridge for instance number 2. So I guess he should get his own crown as well, right? Let's see. Let's go to that guy and see who the root bridge is for. We should see something that says this bridge is the root on that guy, right? Because remember, he wasn't the root for anything yet. Show span, and he is the root bridge for MST1. Yes, he is. See, this bridge is the root for who? MST1. What about MST2? MST2, this bridge is also the root. So he's also the root. Now, MST0 is that guy right there. So he is the root bridge for MST's 0, Spanish tree instance number 0, and he is the one for 1 and 2. Right? Y'all see that? So he's the catch-all VLAN root bridge. Y'all with me so far? Run me my likes. Make sure y'all subscribe. We tune in. We usually stream Monday through Thursday, 8 p.m. Eastern Standard Time. Tomorrow is a possible hurricane over here in Florida, so I might not stream tomorrow. It's more of a, it looks like it's downgraded to tropical storm though. So where else were we at here? We ran the show commands. They want us to control the root bridge now. So these root bridges were done automatically. Now they want us to pick specific root bridges. So this guy, again, he is a root bridge for 0, and this guy is a root bridge for instance 1 and 2. They want us to change all of that here. Just like with PVST, and rather with PVST, the current root bridge is selected based on the lowest bridge ID. So it chose it because of the lowest, the MAC address and stuff like that. With the priority and extended system IDs being identical, the root bridge's MAC is numerically smaller than the lowest bridge's MAC. The result is completely unconfigured network. One single switch will be elected as the root bridge, blah, 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 which in my case, we have 2 separate root bridges. There are 2 ways to manipulate it, which we've discussed yesterday. We could choose the root bridge by using the root macro, right? So spanning tree, MST, and then root primary, or we can change the priority. Whoever has the lowest priority with the bridge ID, that gives that person the that makes them the root bridge. The difference between the two is the priority command will set a specific number by multiples of 4096 as the priority, while the root primary command will set the local bridge's ID to 24576. If the local bridge MAC is lower than the current root bridge, or 4096 lower than the current root's priority, if the local bridge MAC is higher, blah, 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 blah. So we could choose the root bridge with either the root primary or choosing the actual priority number, right? Which is exactly what we did yesterday. So right now they want us to modify D1 and D2 so that way D1 is elected the root primary root for MST instance 1, and D2 is elected as primary instance for MST 2. So right now, what we said he is the root for 1 and 2, and he is the root for just 0. So they want us to do this. Make him be the root for, if they don't disappear, MST 1, and he's the root for MST 2. So we'll do that. D1, we say global config mode, and it's spanning tree, MST, what is it? I can't even remember how to do it. Instance? No. Root? Config? MST? No. Root? I can't even remember. I'm going to have to question mark through this. Let's question mark through it. Yes, you pick the instance number and then the root. That's what it is. So we said spanning tree instance number 1 is going to be this guy, right? And then we said we want to make him the root, right? And you could choose a primary root or, you know, a primary root. And then you could choose a backup root just in case this switch go down. So if this switch right here goes down, then we can elect somebody else to be the root bridge, which will be done automatically, but we can pick a specific switch to be the backup root bridge, right? So we're going to make him root primary for MST 1, and then, which he already is, I think. Yeah, he was 1 and 2, right? Yeah, so this bridge was the root for MST 1 anyway, but his priority was 32769. Let's see what it is now. Do show span. Show span. I thought I did the logging console, logging synchronous on this. MST 1, he is the root, but now his priority is 24577, right? Because remember, they said it's going to be 24576 plus the VLAN ID number. Well, not VLAN ID number. In this case, it's going to be the MST instance number, I believe. That's what I think that is. So, and then we want to make him, this guy, the root for instance number 2, right? So let's go to D2, do the same thing. So this is really similar to yesterday's lab, really similar. But y'all know repetition is key. You do this shit a million times, man. You start doing this shit in your sleep. You start learning this stuff, and it's like it becomes nothing to you. And then when you start taking these exams, you just kind of like go through it, man. So spanning tree. Let's do MST 2 and see who is the root. No, I don't want to do that. Let's just do show spanning tree. And then we'll see for MST 2. I'm already the root bridge, but we want to specifically make him, that was done automatically. We want to make him specifically root bridge for MST 2. Spanning tree, we say MST 2, root primary. Now he should be the root bridge for MST 2. So span, go over, Let me make this a little bit bigger so y'all can see all together. MST2. This bridge is the root, but now his priority is 2, 4, 5, 7, 8. Y'all with me so far? Y'all with me? Any questions or anything like that? Let me reload. Make sure, because last time I missed a whole bunch of chats because I didn't reload there. So y'all just quiet tonight. We almost done here, y'all. I can't count up all the steps in this here. So now what it wants us to do after you've configured D1 and D2, go to A1 and issue the show spanning tree root. So now we're gonna go to this guy right here and find out who the root bridges are for those instances, right? So let's see. We'll do that show spanning tree root on A1. Show. We did that already last time, right? Yeah, I think we did it in here. No, we didn't do it last time, but we'll do it anyway. Show span root, and we'll see the root bridges for each instance, MST instance, right? So for MST instance 0, so this guy is 0580. He is also the instance root bridge for MST 0, and he's also the root bridge for MST 2, right? So 0 and 2, and then guess what? This remaining one, MST 0, is the root bridge. This guy right here, he's the root bridge for MST 1. I said 0, 1. Yeah, that's what they pretty much what I wanted to do there. We can see that it's the root port for VLAN 1 and the root port for VLAN 2. So we have root ports there, root port information. Where it is, right there. This is root port information. To get to the root bridge, we take FA103. So let's look at MS2, right? We said he is the root bridge for instance number 2. Instance number 2, he's the root bridge. So to get there, we take the port FA103. So this is our root port to get there, to get to the root bridge, right? So now, if this guy wants to send traffic, guess what? He's going to take this specific link to get to the root bridge before he goes out to the internet, right? That's basically what that's doing right there. And I wish I could do a packet capture so we can test that theory out, but you know, but just by going by these show commands, we can kind of predict our traffic flow like that. What else we want to say? Adjust the port cost values they want us to do here. On A1, they want us to show spanning tree VLAN 1 and let's show spanning tree block port. So we do a show span VLAN 1. And then they want us to do, so we can see our block ports there. We have some alternate ports. Theirs are different compared to mine because I'm using different ports and stuff. Excuse me. We can see which ports are being blocked. So being that this is our root port right here, bloop, this is our root port to get to that. We probably have one of these blocking, right? So A1, who is blocking? That's instance. We can do show span block ports, and these are the ports that are blocked on each instance. Isn't that pretty cool? So now we were talking about, what instance was that? This was instance number 2. FA103 is the root port. So on MST instance 2, 3 is the root port. So we're blocking on every other port, 1, 2, and 4. So that means it's being blocked for MST instance 2. This is being blocked, that's being blocked, and that's being blocked for that specific instance, just instance number 2. That don't mean there's no other traffic going on this port right here. That don't mean there's no other traffic going on this port. It's just that for that specific instance, instance number 2, that port is being blocked right there, right? And there's different ports being blocked for different instances, right? And that's how like spanning tree can get really confusing and stuff like that on what ports are being blocked and stuff like that. It's like layers to this shit, man. There's levels to this, man. So, like I said, it can get pretty complex when it comes to spanning tree and stuff like that. So that's who's being blocked, and that's who's being, now again, that's just for instance, MST instance number 2. MST instance number 2. That is our root port right here. The rest are being blocked, right there. So MST2, we said 3 was our root port, right? So that's why 3 is not on that list. Here's 3, root port. 1, 2, and 4 is being blocked, right? See, 1, 2, and 4. 4 MST instance 2, right? What else we want to see here? We have some alternate blocking ports. On A1, they want us to shut down 1 and 2. So one and 2. They want us to shut down this interface right here and this interface right there, and assign a new port cost of 1,000 to FA02 using the using the spanning tree MST1 cost value command. So let's go ahead and do that. They just want us to kind of like, remember how we had this one being the root port and stuff like that? This guy being the root port. My bad. They wanted this guy to be the root port and stuff like that. And then this guy was blocking right here. And then those two were blocking as well. Well, they want us to change the cost for this one. And most likely they're going to make, because I haven't, like I said, I haven't done this lab yet. They want us to make this probably going to be the root port. And then this guy's going to be blocking. Because remember, when we change costs and stuff like that, that kind of changes the whole topology and how the shit works. So we shut those 2 ports down. 101 or 102. So go to global config mode, interface, FAST. Your interfaces might be different, 101 through 2. We said we got to do the range command, my bad. Range, we want us to shut those ports down. And then they want us to do the spanning tree. This is how we change the cost. Spanning tree, MST1 cost. And then they said 1,000, I believe. They wanted 1,000. Right? We do no shut and see what happens, and we'll see what the block ports now. What the block ports look like. No shut, not no shit. How many times you've done this right here, right? Man. And then now let's do a show block ports and see what's blocking and stuff, right? Show span block ports. So for instance 1, what was we looking at last time? We were looking at MST instance number 2 now, last time, right? Let's look at what our root ports look like. Show, what is it? Show span, they said VLAN 1. Why VLAN 1? Let's see. Why they want us to do VLAN 1? So now, 1, 2, and 4 is blocking, which it was, and then 3 was the root port, even though we changed the cost. Interesting. Those 3 are still blocking right there. So I don't know what the hell they wanted to change there. But let's do a show. Let's see. What was the what was the intended effect here? No. Let's look at MST1 though. Let's look at MST1 and see what it is. Let's see what happened there. Show MST1. Now, our root port for MST1 is 101. This is our root port. Our port to take us to the root bridge of MST1. Right, so what port was that? 102. So now this right here is our root bridge to take us to the root switch. For that specific instance though, MST1. We were looking at MST2. I should have been focused on MST1 here. Let's see what else they want us to do here. They want us to show our spanning tree block ports, which we just did already. From the output, you can see the root port selected for A1, selected by A1 for VLAN 1 is now FA02, and the port is now cost is 1,000. So, and that's what it was right there. That's what we changed right there. So, what else I want to say about that? Y'all got any questions or anything so far, man? Y'all remember my likes buttons? So hit that subscribe button. Make sure you join that Discord server. We only got a little bit left for this lab, and then we're going to call it a night. join that Discord server and I'll share my spreadsheet with you guys, the study spreadsheet. So that way you can kind of follow along what we're doing throughout the week and stuff like that. Again, I'm studying for the CCNP NRC exam actually, and my certification doesn't expire until like 2023. So I'm just like streaming and just kind of like learning this stuff on the way. So I'm not like in a rush to kind of like get all this stuff out of the way so that way I can take this exam. I'm taking my time to learn this stuff, right? So, no, I wanted to show y'all the spreadsheet. Where is it at? This is the spreadsheet right here. So again, we're covering that lab. Yesterday we did not that lab. Today we're doing this lab right here. And y'all might see some highlights on y'all copies, so y'all could change it up if y'all want to. You could like be like, nah, I don't want to use that one-on-one labs book. You know, I want to use something else. If you want, you can try, change it up if you want to. But make sure you join my Discord server. You can get a copy of this spreadsheet right here, and it breaks down where each topic is from the book and stuff like that. And from each of these books and YouTube videos, it links to some YouTube videos and stuff like that. And hopefully if you have a CBT number subscription or you subscribe to this guy named NetworkBruh, who gives fire content, you'll see some of my stuff on there as well. So if you want to copy this spreadsheet, make sure you are joined to my Discord server. Here's the invite. And let's move along through the rest of this lab right here. We haven't seen Professor Black Ops for today, for giving us the stigs of the day today, did he? Maybe he's tuned in. What exam are you studying for? I'm actually studying for the ENCOR exam, but I don't have to take it because I already took the switch exam and the route exam before, Cisco changed it all up. So now, being that I already took those exams and they couldn't give me the CCNP because I didn't take T-Shoot yet, they just said, here's a badge. You don't have to take ENCOR, but I still have to take an elective exam, which I'm going to pick Advanced Routing and Switching, or it's also known as the NRC exam. So I really need to be studying for an NRC exam, but they came up with a whole bunch of new concepts and topics in ENCOR. So I said, I'm going to go back and study. I know I like going back to the fundamentals. I'm going to go back and study what I know off the ENCOR exam, plus the new topics, and then move on to study for the NRC exam, which is what I really need to take. But again, my certification doesn't expire until 2023. That's a while from now. So when COVID happened, they extended everybody's expiration dates and stuff like that because you couldn't take exams for a while. So I got a while before I got to take it. So y'all give me a second here. Intermission break. Intermission. And play some music for y'all. All right, so Jason in the building. We got appreciate you for tuning in. Say, what's up, bro? No stig makes me angry, right? No stig of the day, man. What's going on here? I don't know. I guess Professor Blackhouse must be busy. He got his own channel and stuff like that. Y'all make sure y'all subscribe to him. Give me a second, y'all. Okay, my bad, y'all. Morningstar said might start a YouTube channel. Oh, that's what's up, man. You let us know what it is, and then we'll subscribe and stuff, man. Yeah, me too. But I want to be ready for CCNP. You got me hyped, ready to lab every day. That's what's up, man. Y'all sorry for that intermission right there. So where we at? We got to adjust the port priority values to import root port selection. So next method is to impact root port selection. It's configured on the root bridge itself. In our current network topology, A1 has 2 connections to the root bridge for instance 2, right? We said A1 has root bridge. We said A1 has 2 connections to the root bridge for instance 2. Switch D2. So instance 2 is the root bridge. Or D2 is the root bridge for instance 2, right? And he has 2 connections to it, which is this right here. Another color. This right here and this right here. So you got two ports. Give me a second. So where we at? Just the port priority values. Okay, show spanning tree block ports. My bad, y'all. My bad, y'all. All right, so we did that already, right? Show spanning tree block ports. We're gonna wrap this up in a minute here too. So now he don't have any many ports being blocked on MST1. Let's see here. We did that already. Adjust the port priority values to impact the root port selection. Show span MST2 and take note of the port ID values listed. Okay, so let's do a show span MST2, which is what we were talking about here, right? So for MST2 right there, span MST2, and we have one forwarding port, which was F103, right? So this was the one that we looked at right here, right? We said this one was the only one. So this is the root port for it, right? Green. That's the root port to get to MST2's root, right? That's MST2. And then the rest are blocking. 1, 2, and 4 is blocking. So 1, 2, and 4 are all blocking, as we can see. And then they wanted us to do here to change the port priority. Modify the port priority of D2 interface 106. So this right here, they want us to modify this port right here, right? Because remember, with when we change port priorities right here, we kind of like we're modifying. We're how do we say? You could say tuning. I don't want to say optimizing because you might fuck it up. So we're more like we're tuning the STP topology. So now we're gonna change this interface right here, the port priority, right? Modify the port priority of D2 interface G106, so that way it becomes the preferred port by issuing the spanning tree MST2 port priority value, uses value of 64. So once we do that, then most likely this will become our root bridge, and that's what I think they're going to do here. They're going to make this our root bridge, and then that's going to make probably this one start blocking. Let's see if my theory is correct here. That's what's going to happen. So we're going to go to global config mode. And they actually wanted us to. This must be best practice to do. Shut down the port before you start fucking with the STP topology. So global config mode, and we say interface range. So both of these ports we're going to modify actually. So 5 and 6 interface range GI 10 5 through 6. Shut them bad boys down. It's not GI. Mine is FA. So I've got fast Ethernet ports on those guys. FAST, right? Right? Yeah, so these guys for me are actually fast Ethernet interfaces, right? That's the reason why I didn't command, that command didn't take. So shut those ports down. They want us to change the priority of MST instance 2. Port priority is going to be 6 on interface number 6. So they want us to change just 6 first, FAST. So this port right here, that port right there, which is the one I was pointing to earlier, right? They want us to change that port priority to 64, right? So we said interface FA106, spanning tree, MST2, port priority 64, right? We get out, and then we're gonna no shut that bad boy. Get out. We're gonna no shut the rest of those other guys. FAST range, FAST 105 through 6. We say no shut, and see how that changes our topology and our root ports and stuff like that, right? Down. It's probably going through standing tree, listening and states and all of that other stuff, right? Did he come up yet? Show interfaces status. We did no shut it, didn't we? Interfaces. Why 5 through 6 is You know what? I'm on the wrong one. I'm gonna do a 5 and 6. I'm on A1, y'all. Y'all see, man? Y'all let me do that, man. Like, why is it not coming up? It's not even up. It wasn't up in the first place. So I was doing 5 and 6 over here, when I was supposed to be doing 5 and 6 on D2 right there, right? Y'all didn't catch that, man? Y'all just wait, man. Look at this NetworkBruh guy, man. All right, so let's go to D2 and do the same thing what we just did. Global config mode, interface, range, FAST 105 through 6. Shut those bad boys down. And then we said interface FAST 10, was it 5 or 6 that we did that? 6. We changing that guy to 64. Now we can get out of this, and then interface range, those guys, no shut those guys. They should come back up now. There they go right there. And now, where we at? Now let's take a look at the spanning tree instance. I think instance number 2, which we just changed up, and see how it affected the topology. We'll go to A1's perspective, right? So now, remember last time we had, what do we have? We had this port right here as the root port for MST instance number 2. And the rest of those two guys right there, this was blocking, that was blocking, and obviously this one was blocking, right? Now that we've changed the port priority and stuff like that, what happens now from A1's perspective, right? South show span MST, what is it, 2? So now FAST 104 is the root port. So now this guy is a root port to take for MST2, and then that guy obviously is blocking. Why? Because we changed that port priority, right? So now I forgot which one I said was blocking. Let's do that over again. We said this guy's blocking. We said 3 is blocking now, right? We said this is blocking, that's blocking, that's blocking, and now this guy's our root port. So now, again, we had the internet, right? We're gonna draw this little ugly nappy-headed internet right here. So now when we need to get to the internet, this PC right here, he is not gonna take this port, he's gonna take that port right there, because that's the root bridge, since D2 is the root bridge for that VLAN. So when we send traffic on that VLAN, he's gonna take that port to get to the internet, instead of going to this port, because we changed the port priority. And that is, like, for some reason, like for whatever reason, we can make maybe this is more of an expensive link, or who knows. we could do that. Just know that we could do that. Okay, so what else they wanted us to do there? And I think that looks like that's all they wanted us to do. Show spanning tree MST. Yep, and they just basically, so yeah, basically what we did was we created MST instances, or we created VLANs on all these guys, right? We did VLANs 1 and 2 and mapped those guys to instance number 1, I believe. Correct me if I'm wrong, I can't remember, but it's something similar to this, right? Y'all know I got the memory of a goldfish. And then we did VLANs 3 and 4, and we mapped those guys to instance number 2, right? Then we made this guy the root bridge for instance 1, this guy the root bridge for instance 2. It might have been backwards. It was something similar to this, but either way, we made D1 a root bridge for a specific instance, D2 there's root bridge for another instance. So, and then we kind of like changed the port priorities to make sure that instead of taking this link, we're going to take that link. And that's pretty much all what we did, man. So again, MST is one of those spanning tree flavors. It is open standard. You can use it in a mixed environment. So you can use it with a Juniper switch, with a Arista switch, and you can mix and match it with different flavors of spanning tree. So you can have a rapid switch running rapid PBST and another switch running MST. Why the hell would you do that? But you could do that. And also MST kind of puts its less overhead on the CPU, because it's instead of having a separate instance for every VLAN of spanning tree, so one instance, one VLAN, we have a spanning tree instance for that, VLAN 2, a spanning tree instance for that, VLAN 3, a spanning tree for that, etc., etc., etc. We can map all of those VLANs into one instance, and another separate set of VLANs into another instance, and then have less instances of MST, or not instances of MST, less instances of spanning tree. What the hell am I saying, right? You can tell this is the end of my stream, and I'm just ready to wrap it up. Wrap it up. Anyways, y'all want me my likes. Tomorrow, I may or may not stream, because like I said, we're about to get hit by a hurricane tomorrow. But I think it's downgraded to a tropical storm, so I may or may not stream tomorrow. We typically stream Monday through Thursday, 8 p.m. Eastern Standard Time. If y'all want a copy of this spreadsheet here, make sure y'all join my Discord server, right? This spreadsheet has all of the stuff that we're going to cover on the ENCOR exam. Again, I don't have to take ENCOR exam. I'm just kind of going over this stuff and trying to teach what I know and try to make it, teach it in simpler terms and stuff like that. And y'all know I just like labbing every day, man. This shit fun to me. So we did this lab right here. Y'all might see some different highlights. That just lets me know I covered that part. And maybe I'll do that some other time or whatever. We may do MST again using Boson NetSim. I do have a new version of that. Once I get to 5,000 subscribers, guess what? Your boy's going to do a giveaway, right? Boson has gifted me with a promotional copies for my personal use, but I'm also going to work on giving away a couple copies as well for a giveaway. So make sure y'all tuned in. Make sure you subscribe to your boy. For now, comment, like, subscribe to the network. I ain't have my bonnet on today too, so